Okay, in these notes we're going to do a little more work with solving by factoring. In the last notes we took, we kind of looked at the basics, right? This is exactly how to do it. And in these notes we're going to keep doing the same work. It's just some of the examples will be a little more in-depth as far as the solution goes, but for all purposes, it's the same work. You do the same thing. So just a reminder, you set the equation equal to 0. So everything on one side and 0 on the other. Factor completely. Set each factor equal to 0 and solve. And again, a reminder, all of the ways that we have learned to factor are GCF. You should always look for a GCF. Grouping if you have 4 terms. The AC method or big X for trinomials. And the difference of squares pattern where you have a perfect square minus another perfect square. All right, so the first 3, actually the first 4 here, are already factored for us. So they've been set to 0, they've been factored. All we have to do is find the solutions. And so just like step 3 says, we set each factor equal to 0 and solve. So x plus 6 equals 0, and x minus 1 equals 0. And then you can see it's just the opposite of these numbers. X equals negative 6, and x equals 1. So we have our 2 solutions here, 6 and 1, or negative 6 and 1. Now, when it gets a little more complex is when you have a leading coefficient here other than 1. And so our factors here are 2y plus 1 and 3y minus 3. And so the only difference here is that you'll have a division step as well. And so you could get a fraction, but that's okay. So if we solve this one, set 2y plus 1 equal to 0 and 3y minus 3 equal to 0, and we're going to solve. So first step is just, that pen is too big. First step is to subtract 1 to y equals negative 1, and then divide by 2. And so for this first factor, we get y equals, just leave the fraction, negative 1/2. If we can reduce it, reduce it or simplify, but you could just leave it like this, negative 1/2. And for the second factor, we're going to add 3. So 3y equals 3. Divide by 3, and y equals 1. So our 2 solutions for this problem are negative 1/2 and 1. So we can get a fraction, that is possible. And that's okay. That can happen. Number 3, set these equal to 0 and solve, because again it is already factored. So 4r minus 5 equals 0 and 2r plus 3 equals 0. So we're going to add 5 to both sides. 4r equals 5. And then divide. And so we get the fraction 5 over 4. And I, again, would recommend just leaving the improper fraction. There's really no need to change it to a mixed number or a decimal. You could just leave it like that. We can't reduce it. We can't simplify. Just leave it alone. On the other factor, we'll subtract 3. 2r equals negative 3. And then divide by 2. So r here equals negative 3 over 2. And again, just leave the improper fraction. There you go. And remember, you can always also just list the solutions in like this with a comma. But if you've already got them written down, like down here, just circle it. It's okay. Either way is fine. Let's go over here to number 4. So here it looks like it was factored by a GCF. We've got a 3d and then a 10d minus 5. Probably could have taken out another 5, but that's okay. So 3d equals 0, and 10d minus 5 equals 0. Well, this one is just going to be 0. Divide by 3, we get 0. 10d minus 5, we need to add 5. So 10d equals 5. then divide by 10. And here's what I mean when we say we can reduce, right? We have 5 over 10. That can be reduced to 1/2. Divide them both by 5. 5 over 10 isn't wrong. That's not an incorrect solution. It's just not simplified. So, if you left 5 over 10, technically it would be correct. But it's always a good habit to reduce fractions if possible. Now, all my pens are cartoonishly large. Okay. So d equals 0 and 1/2 here. Okay, now we'll have to factor on our own. So for this first one, number 5, we have 3f squared minus 7f. This is a binomial, so you should check for difference of squares. It is clearly not two perfect squares. And so check for GCF. We can take an f out, and that leaves 3f minus 7. And those are our two factors, f and 3f minus 7. Well, clearly f equals 0 is one solution. And then 3f minus 7 equals 0 will solve this. So add 7 to both sides. 3f equals 7. And then divide by 3. And so we get the fraction 7 over 3. Can't reduce it, just leave it like that. 0 and 7 over 3. So the number of solutions you get should match the number of factors that you have when you factor it. We have two factors, so we have two solutions. Okay, first thing we have to do here is set this equation equal to 0. So I like to leave the x squared term where it is, especially on the left. It just feels nicer. But more importantly, I like to have a positive here. Not 100% necessary, and sometimes it will be negative, but if it's positive, just mentally, I like to leave it where it is, but you could always go the other way here and subtract 2x squared from each side. So anyway, we end up with 2x squared minus 2x minus 4 equals 0. Okay, so we have to move those other two terms to be on the same side as the 2x squared and leaving just a 0 on the other side. Okay, so we can factor now. And we could look for a GCF, but we don't have to because we're just going to get the solutions. And so if your factors aren't as simple as possible, if you have a constant GCF you could still take out, it doesn't ultimately matter. So we need two numbers that multiply to negative 8, 2 times negative 4, and add to negative 2. And that's going to be negative 4 and positive 2. So we're going to split that middle term here. 2x squared minus 4x plus 2x minus 4 equals 0. And now let's factor by grouping. So we can take a 2x out. That's x minus 2. And we can take a positive 2 out, leaving also x minus 2. So our factored form is x minus 2, and then 2x plus 2. And yes, looking for a GCF at the beginning would have made that process slightly easier, so feel free to do that if you like. But it is not 100% necessary. It's only necessary if you can take a variable out. So if all of these had an extra x, if it was something like 2x cubed minus 2x squared minus 4x, well then we would have to take a GCF of at least an x out because we would have 3 solutions in that case. But we are just looking at quadratic equations here, so you won't have any like that. Anyway, let's finish this problem. We have x minus 2 and 2x plus 2. Those are our two solutions, or two factors, excuse me. We need to find our solutions. So set those equal to 0. We're going to get 2 for this one. X equals 2. And after we subtract 2 and divide by 2, we get x equals negative 1 for our second solution. So 2 and negative 1 are our solutions there. 2 factors, 2 solutions. 2 factors with an exponent or a variable. Because if you took a 2 out as a GCF, that wouldn't affect your solution because it wouldn't have a variable. It would just be a constant. All right, let's go to number 10 apparently. Skipped 7, 8, and 9, but that's fine. Okay, we got 6x squared minus 13x minus 5. We need to find 2 numbers that multiply to negative 30 and add to negative 13. Well, I think that'd be 15 and 2 somehow. The sum is negative, so we need a negative 15 and a positive 2. That'll do it. So let's split that middle term. 6x squared minus 15x plus 2x minus 5 equals 0. And now we can factor by grouping. So we can take a 3x out of this first pair. That's 2x minus 5. And we can take nothing, just a 1. And then that will leave the 2x minus 5 we need. And so now our factored form is 2x minus 5 and 3x plus 1. And now we can solve it by setting those 2 factors equal to 0. So 2x minus 5 equals 0 and 3x plus 1. And the more you do this, you can get used to how it works, right? We're going to move this 5 over by adding it, so it'll be a positive 5. And then we'll have to divide by 2. So we know what fraction we're going to get. It's going to be the fraction 5 over 2. I did a different color. Okay, so you can start to see kind of the pattern here and how the work will turn out, and you can start to take shortcuts if you're able to. And if you'd rather just do the work every time, that's okay too. That's definitely playing it safe and making sure you get the right answer. So we get negative 1/3 for that one. So subtract 1 and then divide by 3, you get negative 1/3. So there are 2 solutions, 5 over 2 and negative 1/3. Okay, number 11. Lost it. Here we go. Yeah, we got it. Number 11. We need to bring all this to one side. So we're going to subtract the 10 to cancel it out. So 3x squared minus 13x minus 10 equals 0. And now we can factor this. So we need 2 numbers that multiply to negative 30. And add to negative 13. I think we've seen this before. Negative 15 and 2. Just had this. So let's go ahead and split that middle term. 3x squared minus 15x plus 2x minus 10 equals 0. Okay, we factor by grouping. Take out a 3x. That's x minus 5. Take out a 2. Also x minus 5. And so our factored form, we have the x minus 5 and the 3x plus 2. OneNote is giving me some problems right now. Pretty laggy, but that's a problem for me, not for you. There we go, 3x plus 2. Okay, so now we can solve by setting these factors equal to 0. So x minus 5 equals 0, and 3x plus 2 equals 0. We'll solve this one by just adding 5. So the solution is 5. And here we have to subtract 2 and then divide by 3. That would be x equals negative 2 over 3. So 5 and negative 2/3. And that is number 11. It looks like quite a bit of work, but remember, I'm writing every single possible step out for the notes. So if there's any place you can save yourself some time, whether that's in your factoring or when you get to the factors, if you can see what the solutions are, feel free to take those shortcuts when possible. This is a difference of squares pattern, so factored form is pretty quick to get to. Because the square root of 49x squared is 7x. The square root of 25 is 5. And then we just need plus and minus between them. And now we can solve. And when you have a difference of squares, typically, it might be always, I don't usually like to say always, but I think this is always, you'll have plus and minus the same number. So here we're going to subtract 5, 7x equals negative 5, divide by 7, and you get negative 5 over 7. And on this side, we'll add 5 and divide by 7. So 7x equals positive 5. And we get positive 5 over 7. So our answer was positive and negative 5 over 7. So whenever you have a difference of squares, and I think it's, if you think about the solving by square root notes we took, you could use square roots to solve this type of problem as well, and that is why you get plus and minus the same number. So just some more practice on solving by factoring. Factor completely, set each factor equal to 0, and solve those two equations that you have.